thank the organizers for selecting my talk today, selecting my abstract as a talk. I have no disclosures. So it's known that in lupus and autoimmune disease in general, these autoimmune diseases are characterized by B-cell selection defects at the transitional B-cell stage. So autoreactivity, we know, is limited in the bone marrow by central tolerance mechanisms, and the B-cells that survive these central tolerance mechanisms egress out of the bone marrow and go through a series of transitional B-cell stages that we call the T1 and T2 B-cell stages. And from here, the T2 B-cell stage, they can mature into either marginal zone or the FO B-cell, or they can be deleted after going through this IgM low T3 B-cell stage. Selection at this stage, at this transitional B-cell stage, is dependent on a number of factors. So we're familiar with the influence of BAFF at selection at this transitional B-cell stage. The BCR signal strength is critical here, but what I want to talk about today is another factor that we think has a unique ability to augment selection at this stage, and that is IL-17. So BXD2 mice provide a really ideal model for studying B-cell selection defects and B-cell tolerance loss. These mice develop a spontaneous systemic autoimmune disease. They spontaneously develop large germinal centers in their spleens and anti-nuclear and ribonuclear protein autoantibodies. They have the classical ANAs here. And this is a picture just to give you a general idea of how profound the B-cell tolerance loss is in these mice. These are the global picture of a pepperprint microarray that we did, and on this microarray chip are over 3,000 peptides. These are peptide epitopes that have previously been associated with human autoimmune disease. And when we probe this chip with our serum from our BXD2 mice that have developed disease, you can see just how profound and widespread the B-cell tolerance loss is in these mice. And so this is just a summary of the pepper chip results here to show you that when we look at the top 100 epitopes, there's a predominance of epitopes that derive from nuclear autoantigens, and within this there is a predominance of autoantigens that are ribonuclear protein in origin. So this mouse is a very lupus-related relevant mouse. We used a LA and SNRNP tetramer strategy to isolate autoreactive B cells and BD2 to get at this question of B cell tolerance. And this involves dual staining with a nonspecific peptide tetramer and a specific autoantigen tetramer that consists of biotinylated peptide epitopes deriving from LA and SNRNP that we identified based on our peptide microarray analysis. So this enables us to isolate the B cells and study them specifically. So from our tetramer experiments, we know that abnormal development of autoreactive B cells occurs early at the transitional B cell stage in BXD2 mice. So when we look at LA-positive B cells, the total B cells here, total LA-positive B cells, and then we can gate down further on the transitional B cells on the basis of CD93 expression, which in mice defines a transitional B cell population. And then further we can subgate on T1, T2, and T3 transitional B cells on the basis of surface IgM and CD23 expression. And what I want to call your attention to here is there's this accumulation of T3 B cells in the BXD2 mouse, where in the B6 mice, the predominant population is the T1. There's this skewing away from the T1 towards the more mature T2 and T3 in BXD2 mice. So what is this T3 B cell compartment? This B cell compartment has been described very well in mice. There's also an analogous population in humans. humans, it's been described, the characteristic thing about these B cells is they're IgM low, they're IgG high, and in mice CD93 positive. They've been shown to be enriched in autoreactive specificities with an anergic or unresponsive phenotype in some models. And given that these B cells are not deleted immediately, it's very important that the anergic status of these cells is maintained to prevent the autoimmune disease. So we wondered, are the expanded T3 B cells that we see in BXD2 mice, are they truly anergic as suggested by some of the literature and some models? And to answer this question, we made use of the high surface IgD expression on both T2 and T3 B cells to examine the responsiveness of these subsets. So we measured activation response by looking at CD69 expression after IgD stimulation. So from this we can see that the T1, T2, and T3 B cells from BXD2 exhibit a higher CD69 activation after anti-IgD agonist CL264, where from T1 to T2 we see a big increase in the CD69 upregulation and a similar increase from T2 to T3 here. So what could be the mechanism that underlies this accumulation of the T3s and their activation or loss of energy? So we know that there are multiple mechanisms for survival and activation of autoreactive B cells, increased availability of BAFF, T cell help, TLR signals, defects in apoptosis. We know that for B cells, the NF-kappa B pathway is a very critical pathway for determining the activation and survival fate of B cells and autoreactive B cells. So where does IL-17 receptor signaling come into this? So we propose that this is another mechanism that can promote or augment the survival of autoreactive B cells. And the important point here is that IL-17 receptor signaling, we know from our work and from others, it signals B cells through the NF-kappa B phospho-P65 signaling pathway. And you can see here, after IL-17 stimulation in BXD2 B cells, there's a rapid upregulation of phospho-P65 within 5 minutes in these B cells. So we looked at the transitional B cell distribution in our IL-17 receptor knockout BXD2 mice, and these are the results from that, and this is within law-positive autoreactive B cells. So you can see here that, again, there's this accumulation of T3 B cells in the BXD2 mice, but when we look in IL-17 receptor knockout mice, this distribution is normalized back to what we see in B6 with the predominant T1 population and a decrease in the T3. So this led us to hypothesize that IL-17 may act at the early transitional B cell stage to break B cell tolerance. So we wanted to know first of all which B cell subsets express the IL-17 receptor. Do transitional B cells even express this? And so these are the results from that. You can see, as we previously have shown, the germinal center B cells express the highest levels of IL-17 receptor, but just after these B cells, the transitional T2 B cells actually express the highest levels of IL-17 receptor. So this is very, very interesting that these pre-germinal center B cells express such high levels of the IL-17 receptor. So we wanted to look at the activation status of different B cell, transitional B cell subsets in BD2 mice. So we looked at basal phosphotyrosine levels as a correlate of B cell activation in vivo, and found that the phosphotyrosine levels jump up here at the T2 stage, and that this is maintained through the T3 and MZ and FO B cell stage. And so when you look at B6 and the IL-17 receptor deficient mice, you can see that this elevated phosphotyrosine level is normalized. Furthermore, even when the B cells are stimulated through various molecular pathways, like using anti-IgM to stimulate the B cells, or anti-CD40 plus Ig, the MAI and that even with all these stimuli, deficiency of IL-17 receptor signaling normalizes the proliferative response in BXD2 B cells. So in conclusion, we found abnormal development and activation of transitional B cells in BD2 mice. There's an accumulation of autoreactive T cells, and that this is normalized by IL-17 receptor alpha deficiency. IL-17 receptor deficiency promotes an energic B cell phenotype that's associated with a lower canonical NF-kappa B phospho-P65 response and a lower basal protein phosphotyrosine in transitional B cells. So our results suggest that factors that can regulate the NF-kappa B signaling strength in B cells has the potential to break B cell tolerance at the transitional stage. So last, I just want to acknowledge and thank my mentor, Dr. John Mounts, and also Dr. Wei-Chin Su for all of their support on this, and all the members of the Mounts Lab, and some people here who helped with the tetramer generation. With that, thank you, and I'm happy to take any questions.
Very nice work. I know that your study is focusing on the transitional cells. I'm curious about all the other cells that weren't transitional. Were those naive? Were they ignorant of law? And they seem to be in both the B6 and the B/D2.
Right. We noticed that. Yeah, that was one of the first things that we noticed, that with the tetramers, we see tetramer positive or autoreactive B cells in all the populations, and most of them are naive. The follicular B cells is a huge population, so there's naive. Follicular is the largest population, but yeah, all of the subsets are represented there.
So do you have any thoughts on why all those naive cells are even in B6 but don't respond?
I think that they're probably low affinity autoreactive B cells. They all have expressed some level of autoreactivity, and as to why they don't respond in B6 mice, they're energic. They just are a very energic response, and we think IL-17 at the transitional stages is one factor that can definitely promote this energic status.
Thanks.
Receptor deficient, you mean receptor A deficient?
Right.
And can you speculate on which IL-17 family member may stimulate the cells to the receptor A?
We're not sure about that. We can't exclude anything right now, but yeah.
So you are talking about the birth tolerance checkpoint, and how about the birth tolerance checkpoint in these mice?
So you're saying the check? I mean, in the literature, checkpoint 1 it refers to the checkpoints in the bone marrow, these selection mechanisms, the native selection there. But checkpoint 2 is at the transitional B cell stage. So typically thought of from the T1 to T2 B cell stage, and part of this has to do with I think access to the follicle that can rescue B cells from deletion. So yeah, that checkpoint 2, is kind of what we're focusing on here.
Can I just ask if your IL-17 receptor deficiency was ubiquitous, or was it B cell specific?
It's pan. It's all.
It's pan. So do you think that this effect is an intrinsic effect on B cells, or do you think there's some kind of inflammatory stimulus, whether it's maybe more indirect? Do you have a way to look at that?
That's really important. So we're making we have the blocks for IL-17 receptor B6 mice, and we're crossing them with some CD23 Cree and other Cree mice to address that.